Hey there, IT 145 students. So in this recording, we're going to go through the second half of zyBooks, and we're going to dig into variables and data types in Java. So keep in mind that we get to use variables to remember values. So the purpose of using a variable is we want to keep that value stored while our program is running. And so regardless of the programming language, really what you're doing when you declare a variable is you're saying, computer, give me some memory that I can hold a value to. And then that name that you associate to the memory is what you reference it by. So we would have said num people, that's a variable. The computer is going to take a chunk of memory and it's going to reserve it. And in the program, it can reference it by num people. This would be a lot easier to reference it using a variable than by having to know what its memory address is in some hexadecimal form. Okay. So keep in mind we're declaring variables so that we can save values. So variables and assignments, two different things. The variable is the name that we're going to use to represent the value. Assignment is when we actually place a value in it. Now, we could be doing something like this where we're just putting in a literal value and saying X, you're going to get 5. We could do something where we say some variable Y, you get whatever is contained in X, right? You can use variable values. You could even perform arithmetic. I could say, Z, you're going to get whatever X is currently plus 2 more. So the assignment happens when you use the equals operator, the equal symbol here to place a value in it. Now, this is not checking if they're equal. This is saying put 5 in X. Always on the left side of the statement is what is going to be placed into memory. So the left gets what's on the right. And you can't perform algebraic arithmetic like this. You can't do like x plus y equals 5. That's going to be a syntax error. And again, as they pointed out, we can perform action where there is a variable on both the left and right. We could even reference the exact same variable. I could say, all right, I want to take whatever x is currently, multiply by 20, save it back to x. So in this code right here, this would start out x is 1. So right here, I'd have 1 times 20. That's 20. So x is going to hold 20. Next time through here, I'm going to have 20 times 20. So it'd be 400 is what gets saved into x. There's also a shortcut notation. We'll talk about that in a little bit later section. So in Java, we have an integer type variable, and we use the int keyword to specify that we want an integer type value, whole numbers. You can't have a decimal part that gets saved to this. So unlike Python, you have to specify a data type. So we say int user age, and again, it goes to computer memory. It's going to reserve a block of memory where it can only store an integer value. And again, we can declare as many variables as we want. So you can see they've got one for litter size here, yearly litters, the annual mice. Those are all integer values. We can only assign a int value to these. So let's just copy this code right here. And let's paste it into Eclipse. So if you don't have it up and running, go ahead and get it up and running. I'm just using the same one from the initial recording. So if I try to put in here 3.5, I get an error. It's saying that this is not an integer literal. This is a double literal. So we cannot put in a non-int value to an int data type. And again, we can work with variables on both sides. So they've got two variables, your friends, total friends, and you can see that they are using variables on both sides. They do point out a common error is when you have that order mixed up. Remember, this is not a reflexive statement like in mathematics. This is whatever's on the left is going to get whatever is on the right. So left side always gets the right side. Oh, by the way, I want to come back here and point out that when we declare these variables and then assign a value to them, we can actually work with them. If we never assign a value to a variable, so I'm going to comment out this line right here. So litter size right here, this has never been given a value. And you can instantly see there's a compiler error. If I hover over this, it's going to say this variable may not have been initialized. If I try to run this, because it's got an error, it's never going to work. So this is a little bit different than other programming languages. For instance, in C++, when I declare a variable, it's going to get whatever is in that memory location. Java has it locked down. You have to eventually provide a value to this variable in order for this application to actually run. We've kind of already gone through this, but in our code guidelines, your identifiers for variables or methods, keep in mind they can use any letter, the underscore, dollar sign, and digits. I've never seen a dollar sign used in code, so don't do that. The only time that the underscore is really used is for constants, where we use that to separate the new words of a variable. You must start your variable names or identifiers with letters, underscores, or the dollar sign. And again, nobody ever uses the dollar sign. I've never seen it. You definitely cannot start it with a digit. It's pretty typical that a digit is going to be at the end of a variable. They also point out that Java has what are called reserved words or keywords. You cannot declare a variable with any of these keywords. So for instance, int is used to specify that a variable is going to be an integer type. So if I try to come in here and say, I'll declare a scanner object, int equals new scanner system.in. Let me get my import taken care of. I already have it. So it's gonna say scanner cannot be resolved to a variable. Think scanner is the variable here because int says just error on this token. I can't have that. So I cannot try to use int as a variable name. So I'll use keyboard for my scanner, right? I'm gonna type in at the keyboard. So make sure that you're familiar with these. These are the keywords, reserved words in Java. Okay, so in your intro programming class, you probably did some arithmetic, just like in those other classes. In Java, you can perform simple arithmetic, add, subtract, multiply, divide. You can perform it between variables. It could also be performed between a variable and a literal value. And computer programming follows order of operations. It's going to perform anything in parentheses first. The negative sign is going to be performed, to take this and make it the opposite. Next, you have multiplication, division. There's also a modulus operator where we get the remainder of a division. Then we have addition and subtraction. And again, keep in mind it always goes from left to right. So order of operations always applies. They have some examples down here. So if we want to calculate some calories, quite a bit of calculations that have to happen. And they also perform using parentheses to group things and perform things in a proper order. So always make sure that you're following the formulas correctly and then translate them into the code using the right symbols. I mentioned that Java has a way to do some shortcutting where if we have a same variable on both sides, we might have wanted to add 1 to a user's age. And so we could have performed this action using the plus equals 1 notation. So we might have in here, I'll just put that in here, int user age equals, we'll say they're 40. And then if I do user age plus equals, so I'll do equals user age plus 1 if I can type. So this would make it take the previous value, which was 40, adds 1, so this would hold 41. We could have also done it this way. So we could add 1 that way. What if we wanted to add 5 to their age? We could just do plus equals 5. Or if I'm just going to increment their age by just 1, then we can use the plus plus notation. So this is going to add 1 to whatever was saved previously. And likewise, if you want to subtract off a value, right, we can do -1. This would subtract off what was there previously. And again, you can use minus minus. This is going to subtract 1 from what it was previously. So all of these are the exact same notation. Okay, next data type we have are doubles or floating point numbers. So you're going to want to think of these as decimal type numbers. So these are numbers that somewhere in it contains a decimal point. So they're not integer values, they're not whole numbers per se, but we say they are real numbers. They have all the numbers. So good examples are 98.6, or what is this, 1/10,000. So this is 1/10,000th, or -55.667. So these are decimal type numbers. Now, the reason we call them floating point numbers is that the decimal point can kind of float in the number. Not really necessarily float here. It's how the computer memory represents the value. Okay, so under the hood, the way that doubles get saved in computer memory, floating numbers, it's different than an integer value. So we can have the data type double. And so miles travel, we can then, again, we saw this in the last recording, we can scan the keyboard for a double value. So it's going to look for a number right here. Now, choosing your variable type, doubles versus ints, always needs to be done properly. Integer values are used for things that are counted. So can you have half a car? No. Can you have a half a pizza? No. Can you have a half of a day? No. So they want these to be integer values. However, something like 98.6 degrees, right, your normal body temperature, that should be a double. So always keep in mind the proper data types. Don't just always make everything a double or a float. Keep things the way that they are supposed to be represented. They do provide some ways of formatting outputs. So if we ever needed to display, say, 4 values of a decimal type number, we use the printf operator and then %.4f. This is going to say, give me 4 values after the decimal. Okay, so we've seen int, we've seen double. So let's kind of formalize the data types in the Java programming language. Now, keep in mind, this is different than in Python. In Python, you have an interpreted environment where the interpreter figures out what you've given it and represents the value properly. In Java, you have to specify the data type that you want. So for an integer type number, Java provides, as you can see, 4 different data types. The one that we've dealt with so far has been the int value. But Java provides ways of representing other integer values, because under the covers, the way Java represents these variables depends on how many bits, how many sequences of zeros and ones that it gives to that memory. So for an integer value, it's represented with 32 bits, and it gives you this range of integer values. So where are they getting that from? Well, in computer memory, you've got 2 choices. It's either a 0, 1, so that's 2, and then you have 32 bits. So 2 to the 32nd gives possible range with 4,294,000,000, blah, 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 values. You can see that this is then split in half because this has both negative and positive values. So they divided this by 2, and then somewhere they have to put the other 1. It's not perfectly symmetrical because 0 is in the middle. So they subtract 1 off of the maximum size. So right there, that is 2 to the 32nd divided by 2 minus 1. That's the upper range of an int value. We can do the same thing. So if I wanted to represent a short, it's 2 to the 16 divided by 2 minus 1. So there's that upper range right there. So if I know that I'm going to be dealing with really small numbers, then I use a byte. And I'm going to use 8 bits of memory, so 1 byte of memory. So if I had to be concerned about memory, then I need to really make sure that I use the right data types. If I have a number that's going to be outside of this range of about 2 billion-ish, then I can use a long, and I get a really, really big possible value that I can represent. 99% of the time, you're going to use an integer value in the work that we do in our course. Okay, so 99% of the time, you're going to use an int. Scrolling down, we have the 2 floating type data types. So we have a float, which is using 32 bits of memory. And then we have a double. And the reason they call it a double is because it has twice as many bits as a float, so 64 bits. Now, the way that floats and doubles get represented in computer memory give you 2 things. It gives you the supported number range. So you can see here a float can represent something like 3.4 times 10 to the 38th. It's a really big number. And a double represents something like 1.7 times 10 to the 308, a huge value, okay? So one, you get these huge number ranges that can also contain decimals, but the other part about these is the precision that you're going to get with the double or float. So you're only going to get so many places after the decimal that are significant digits. Oh, it's right here. I thought it was down below. So they're telling us here for a float, while we get this huge range of values, you are only guaranteed 7 significant digits of accuracy for the float type. For a double, you get 16 significant digits of accuracy. So that means after the 16th digit, if it's a double, the accuracy of the value is not guaranteed. Okay. So again, I know all of you probably had some chemistry at some point. You've talked about significant figures, significant digits. It's the same idea here. Now, just like in an integer type, so if I try to save something bigger than 127 to a byte, it's going to have an overflow error. If I try to represent anything outside of these ranges, same thing holds true with floats and doubles. If I try to have a number outside of these ranges, it's going to be an error. Okay, next thing, we have constants. We're going to declare constants for some variable value that should not change. So for instance, we're going to calculate maybe something dealing with speed of sound. So they have speed of sound, it's 761.207 miles per hour. So that is a constant declared with the final keyword. And then to denote that it's a constant, we typically use all capital letters with underscores between each new word. So that way, when I come down here, even though I could hover over it in the IDE and see that its value and see that it's a constant, it just is a nice reminder to the programmer that this is a constant. Oh, by the way, when should you declare constants? Anytime you have some kind of magic number. So we don't want to come in and see, well, why is there 761.207 right here? What is that number? What does it represent? It helps us understand what things represent. A lot of the time for our course, you're going to use constants when you have a menu choice that you're picking from. So you're going to have like 5 menu choices of action that the user is supposed to perform. I want you to declare constants for those, so that way we can represent what they are instead of just saying, well, what does menu choice 2 represent? Okay, next thing. So again, kind of continuing on with our numerics here. Java has a math class, just like every other programming language. So in the math class, it has things like square root, the power operation, absolute value, and so forth. To use the math class, you just simply type math, capital M, that's the name of the class, the dot operator, and then whichever operation you want. So for instance, I can go math dots, and again, I can see I've got all sorts of options, absolute value. There's trig. I can do floors and ceilings. It's got logarithms. So if I want the square root, right there it is, square root. And so square root of user age. So great. One thing to keep in mind is in an IDE, you can hover over the method and you can get its Java docs. You can get the documentation regarding it. So I can see that this method, square root, takes a double as a parameter. Anything can be treated as a double. And then it returns a double value. And it does give us some details here. If the argument is not a number or less than 0, then it's going to give not a number. So if I try to do -1 in there, it's not going to complain. I'm going to violate my own rules, and I'm going to do the arithmetic right here. I'm going to get rid of all this other code. Delete, delete. So I can take the square root of a -1 and it returns not a number. If I give it 0, I should get 0 back. Great. If I give it a 9, I should get 3 back. And fantastic. Now keep in mind that this square root operation returns a double. So I'm trying to save this double to an integer value. And this is saying this is not the same data types. So this result needs to be the right data type. Now this will compile and work properly. Okay. So always keep in mind, look to see what kind of inputs it requires and what kind of output it returns. Okay, again, we mentioned earlier, we have division operator in Java, but I want to point out something that's different about Java from other programming languages, that in Java, when you perform division using two integer values, doesn't matter if it's the actual number or if it's a variable value, anytime you perform division with integer values, Java performs truncation, because the result has to be the same data type as what you're working with. So if you have two integers, you get an integer back, which means it truncates in Java. So you know that 10 divided by 4 in the real world is 2.5. However, because 10 and 4 are both int values, you're going to lose the decimal part. So you only get the 2 right here. In the real world, you know 3 divided by 4 is 0.75. However, because these are integer values, Java is going to return an integer value, and you're going to lose the decimal part. So it's going to return a 0. Don't believe me? Let's find out. Let's just do the arithmetic right here. 10 divided by 4. It's not complaining. It'll do it. And look, it gives 2. And 3 divided by 4. Run it. It gets 0. So when you perform integer division, it's going to return an integer back. Now, Java is smart enough that if it has mixed data types, it's always going to go to the higher level data type. So if this is a double, then this is going to say, oh, int and double, doubles the higher data type. I'm going to give you a double back. So this is going to give me 0.75. Okay. So we'll see some other ways of fixing that here in a little bit. Um, Things that you can't do, you can't divide by 0. So if I try to do a 3 divided by 0, run, we get an exception, arithmetic exception, saying you can't divide by 0. Again, the modulus is going to give you the remainder. We're going to kind of skip over it for now. Remember I said there were some fixes that we could do. So this 3 divided by 4.0, this works. Well, something else I can do is if I want the compiler to treat this as a double without putting a 0.0, is we can tell the compiler to cast it to the right data type. So we can say, using a typecast, I want you to treat this value, even though I know it's an integer representation, I want you to cast it as a double. So we're going to take the data type and wrap it in parentheses. So this is the notation to the compiler that says, all right, take whatever this is, treat it as a double. So I can do the same thing here. It's going to say 4, take whatever it is, but treat it as a double. So I run this and I get my 0.75. Now, I don't have to treat both of them as a double, okay, to perform this double arithmetic. Only one of them, because it's going to go through and say, oh, one of these is a double. I'm going to return back to you, when I do this division, I'm going to return back to you the right data type. Always avoid using the cast for things. So for instance, int result equals math dot square root of 16. So sometimes the compiler might try to, or the IDE might try to give you some help. So watch this. If I do add cast to int, let me do a number that's not going to be an exact number. So for instance, 18, square root of 18 should be like 4 point something. But when I print out this result, I'm not going to get 4 point something. I'm going to get 4, because I said take whatever this double value is, treat it as an int, which chops off the decimal part. Okay. So watch, I'm going to put a breakpoint in here. I'm going to debug this and watch this. I'm going to see what this is right here. So I'm going to highlight math.square root 18 and I'm going to hit Control Shift I. That's going to perform this action. And look, I know it's like 4.24, but when I cast it as an int, that says chop off all the decimal part and just give me the integer value. So if that's what you want, go for it. But if you know that you need, for instance, with 18, if you know you need the decimal part, then you can't just say, give me the int. You need to return the double value. Okay, last areas that we're going to talk about here. So Java also has the character data type. So this lets you represent a single character. Use the char or char keyword. And again, you can assign a single character to this, and it's denoted using single quotes. So single quotes represents a character. Now, in this section, I kind of go through a lot of details about characters. You're not going to use characters very often in our course. I just want you to be familiar with it. However, you will use strings quite a bit. So Java supports a sequence of characters known as a string. So when I have in memory, each character is going to be represented in a memory slot. And then Java keeps track of where these contiguous memory slots are to represent that string. To declare a variable that's of string data type, you declare it with a capital S string. And then we can assign a string literal. That means it is the actual values that are in double quotations. And you'll also see that I can assign to these, I could assign them to variables of each other as well. They'll do that later on. I can get in from the keyboard, the scanner.next. We did introduce this last time. Keep in mind this scanner.next reads until it finds any kind of white space. So that's not going to be useful. So for instance, let's go ahead and just run this. Scanner keyboard equals new scanner system.in. So string fruit equals keyboard dot next. So if I run this, This is waiting for me to type in a fruit, so I'll type in apple. Great. Oops, I forgot to print it out. System.out.println fruit. Let me run it. I type in apple and it has apple in it. Let's run it this time. Let's type in, we're going to eat some passion fruit. And look, dot next reads until it finds any kind of white space. So because passion, then there's a space, it says, oh, that's it. I'm only reading in this first part. So how do we read in something that has white space in it? So if we scroll down, we use the next line operator. This is going to read an entire line of text. So dot next line, and I can see right here, there it is. This tells me it's going to read the entire text of a line. Now when I run it, type in passion fruit, and it read in the entire thing. So anytime you have something with a space, make sure you use the next line. Okay, that's going to wrap it up for this recording. I will talk to you next time.